Alright, so E is like one of those first questions you guys had asked today where I had to switch some stuff around. Because I don't like having secants and tangents together at the same time. Like if I try to factor this, which is what it looks like it wants me to do, because it's like a quadratic, you can't factor it with you got different types of stuff here. So you've got to make a decision. You either need to figure out how could I change secant squareds into tangents, or how could I change tangent squareds into secants? And so I left this up here from my work for when I had to do it. But if this is the first Pythagorean identity, remember you can find the second one by dividing everything by sine squared, or you could find the third one by dividing everything by cosine squared. So that's what I did. This divided by cosine squared, this divided by cosine squared, and this divided by cosine squared. And this lets me see, hey, instead of secant squared, I could put in tangent squared plus 1. So, and you could do it the other way too if you wanted to. When I place the secant squared, I'm going to replace it with tangent squared plus 1. So I think the first time that came up in the homework was number 31 that you guys had asked about. Just a different Pythagorean identity. So it's still kind of messy, and it's still got a few steps to go, but at least it's only tangents now. So we can distribute it to, we could combine like terms, do as much of the easy stuff as we want, add the 1 and divide 3. Looks like we need to take the square root of both sides. Square root of tangent squared would be tangent. Took the square root of both sides, so I need a plus or minus. Got to deal with this because I got to make it look recognizable. So the square root of 1 is 1, square root of 3 is square root of 3. And I would rationalize it so that it looks familiar to me. But I'm finally ready for the unit circle, where tangent is plus or minus the square root of 3 over 3. So, if you had memorized some of those tangent values like I had suggested a few weeks ago, this is much easier. Otherwise, you have to do a little bit of guess and check to find the spots. But it's always square root of 3 over 3 on the spots next to the x-axis. So here's where it's positive, and here's where it's negative. And now I just need to list those out. So the long answer would be pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. 4 spots in 1 rotation, so you could do that in 4 statements. On the solutions, I went ahead and just did it in 2 because these two are equidistant. They're spread apart by pi. So 1 could be pi over 6 plus pi n. That would get both of those and their coterminal angles. And then 5 pi over 6. And then these are spaced out by pi. So plus pi n. So you could do it in those 2 statements instead of the 4 statements that I had said verbally. Yeah.
Why is it just pi again and not 2 pi?
Just because, well, do you see that there was 4 places in 1 rotation since it was plus or minus? So you could do 4 statements if you want to do plus 2 pi n.
Okay. So
But since I'm only going halfway around, this going halfway around also takes care of that one since it's pi n's away.